Hello. Happy Thursday, everyone. We're almost done with the week, which is great because that means another weekend is coming up. Over here, the weather is supposed to be really nice this weekend, so I am looking forward to going out doing some hiking. Maybe not having to stay in like the last 2 weekends where it was like super cold outside and all snowy and blizzardy and all that fun stuff. And it's spring, so hopefully we should get less of that, entire 3 feet of snow in 2 days type thing. But also, who knows? All right. I hope you're all doing great so far. Hope your week has been going well. What am I working on? Oh, right. Yesterday, very shortly after my stream, I realized that there was a bug in my logic for the bitmap, in the bitmap here for calculate component indexes to delete. I noticed here that if the entity that we're looking at, specifically for the component, is false, as in it doesn't have an entry, it still reports an index to delete. Well, that's a problem because that's going to delete somebody else's component. So I want to basically, okay, so for component name in bitmap, we have these indexes to delete for entity index and entity index here. And what I want to do here is continue if have a guard clause in here. If set that false is before index. Bitmap. Okay, so we're basically our entity index. How do we know if we're false? Entity index of this bitmap is our current, okay, is our current vector. Okay, so if our entity index of this bitmap, so it oh, I have like the function on. That's not what I want. Here. Okay. If all right, if okay, so if bitmap of entity index, if that is false, so therefore if not you, then I just wanted to continue, and that's it. Go on to the next one. All right, so that should actually solve that bug before it bites us in the butt. Oh, do I need to? There. Okay, so the next step is to go into the entity data, and we want to now write in a function that's going to do the delete. So I think is here, yeah, import entity data. Yeah, we got query stuff here. We're gonna have a pub function delete entities by index, because they're gonna be passed in by that map. So we'll have the world generate the map and pass it in here. So it's not going to be exactly the same as the vec bool. This is actually going to be a hash map. MDTR Mdrtrodev. I don't know how to pronounce that properly. MDTrodev. Anyways, good morning, afternoon, evening, wherever you are. Hello. All right, so you're going to be a string, and then in here we're going to have a vector of indexes. So I think usize. And we can return a result. I don't necessarily think like once we do it, it's just done. So I want to basically loop through this hash map, then we can do gets on the other hash map based upon this string, and then deal with them. So for this is going to be the component name, and then these are going to be the indexes to delete. Then we have, okay, so we have our vec of usize. We do need to reverse these indexes. So that's the first thing that I'm going to do, which means you need to be mutable. At the very end, we're just going to return okay to make you happy. Okay, let's first start. We're reversing you. That way we're doing like the indexes from the right to left. So as it shifts everything over to the left, we should be fine. Then we're going to go ahead and we're going to get the vector of components. So which is going to have to be an if let sum. This should like guaranteed work every single time. I don't see a reason why it couldn't work, but we could also just do an if let sum. It's not really that big of a deal. So if let sum components equals self dot components dot get mute, and this is the component name. You can be a reference. All right, so now I have this mutable reference to a vector of the component data. And then I just want to do loop through the indexes to delete. So for index and indexes to delete, I then want to do components dot, is it remove? I think it's remove, and then we pass it the index. And that's it. So then back to mod for the world. Okay, so we have component indexes to delete. We get these from our bitmap. We calculate. So we calculate that. We tell the bitmap to delete them, and then we tell self dot entity data dot delete entities by index and hand it the component indexes to delete. I mean, I think I don't have any errors or even warnings in BBECS. So I'm actually curious if I got this working. Okay, I did. I want to do one more test with the, like, maybe a little bit more of a complexity test inside of this deleting. So we have two entities. We've deleted the first entity and the second entity still exists. What I want to do is make sure that we have entities with different numbers of components. So it's also world.register. Let's do something like a size. And then we can do 3 components total. So you could have a size maybe with component size, and our data is going to be, I don't know if it matters, like we'll just say like 25.0 F32. The second one, I don't want it to have a size, but this third one here, I do. And we'll make you like 50, 0, 32. And you could be like a 15. Okay, so if we're deleting, let's say we now delete this this second one. So I want to update you. So if your location point is this 10, 10, get the ID, and then world delete by ID there. Okay, and then we're gonna come down here. We're gonna query for these. Your length should be 2 now, because there should still be 2 entities in there. These are for queried locations. We have location across all of them. And the first one should be 0, 0, and the second one should be 15, 15. So, this is the first one, so you should be 0, 0. Let's actually go into the second one. Create locations. Application. Okay, so you're 1. You should be 15 by 15. All right, I think we could also query by size. I think things are just working now though. We can add more complex tests for this if we run into weird bugs in Asteroids. So let's head back over there. I guess what I can do is close all these windows. We'll do a git. So you're amend, adding ability to delete. Okay. And let's do a cargo toml in here and bump your version. That way, we'll be able to, we'll be able to just push that up and get the new version going as soon as like we verify that everything is working here. All right, so in the main library, we only have a warning now. We're starting to work with this a little bit before we realized we needed to add the delete in. So I think things are going good here now. We're doing world register, registering all these things. We're trying to insert a message into the world. That's one of the big reasons why we were doing this. So I can't do this now. But okay, so create the player. All this stuff happens. Create asteroid. All right, so create player. You need all these things for a player. For an asteroid though, I don't think we need everything. Like asteroid doesn't need a rotation. It needs a location velocity. I'm guessing it does need an acceleration. Needs a mesh marker. Okay, so it doesn't need that that rotation. Generate asteroid location. Yeah, okay, I don't need to deal with any of this other stuff here. Let's fix all of you. Okay, so create message. Apparently not using that. Get player index. All right, so this is very different. So we have to like start over this again. So get player index. The reason why we're doing get player index is, I don't think, is it just the delete? It may, I don't think this is gonna work anymore. I don't think there's any reason to even get the player index anymore. There might be a reason to get the player ID, but the problem is the size of the vectors are different now. So we should really change you to get player ID. We hand the world in, and you're gonna be a U32. All right, let's just do this over again. All right, so what do we need to do? We need to do a query on the world for everything player related. So we can do let query results. Or maybe this could be just queries. Yeah, I think it's just the queries. Equals, and then that's going to be world.query. We removed query 1. And so you're now, we pass in a vector of names. So this is going to be names. We want a marker. Okay, we have that. Question mark U. Okay, so now we have this vector of vectors. That's really just all the queries together. So we can then just say our marker query is equal to queries position 0. Then what do we care about? So we have this marker query, which is the vec of the component data. We need to loop through this. So you can do for component in marker query. Oh, you know what? We also need the IDs. So this is going to be the entity ID. You're a stir, so that's fine. Okay, so grab you out. Okay, so for component in this, I'm gonna need the index in here. Does everything have a marker? I think that I'm giving everything a marker. Oh no, yeah, because everything will have a marker here. Yeah, it's gonna be fine. So dot iter enumerate at the index and the component. We need to cast the component. So that the wrapped marker is going to be a type of a reference to an RC cell of a string. It's equal to the component dot cast. Once we have that, we can borrow it. wrapped marker. Now we can compare it. So if a dereferenced marker, if you're equal to, then what do I have you as? I have you as, like, what do we put in? Do we just throw you in names? Are you? Oh, I guess I'm curious. Like, what did I actually have? So for create playership, no, this is in the main library. For create player marker, names marker to string, data entity types dot player to string. Okay, so this is what I want. I want the entity types player. Okay, so if you're that, then we found the entity with these two components. We can get the index of the ID, which means we now need to take this ID query, get that out, so that ID component equal to, and I guess we could just shadow all the way down. So we could just say like let ID equals the ID query of position index, and let ID, then we're gonna cast it. Year A, U32. Then we're gonna borrow it. Then we're gonna return it. Now, if we come out down here and we don't find it at all, I think we can just return and none. And we're gonna rename you to get player ID. That should change you here, player ID. All right. Now, just all of our systems need to be updated. Okay, so the draw system for the particles. Right, because, okay, we're querying for all the particles. And it looks like we need, okay, we need the meshes, we need the locations, and we need the color. And once we have those three things, then we can go ahead and draw this out. So let's start over. Let query is equal to, hold that. Oh, particles world dot query. You're gonna be a vec. What did I say? We need the mesh. So this is names mesh. The other thing was we need the locations. And the color. Debris color. I don't think there was any other debris stuff in here we needed, right? Yeah, okay. Just those things. All right, so that gives us those. All right, so we got the query out. Let's go ahead and like break these out into their individual things. This is gonna be the mesh query. Okay, so we extract those out. And then we need to, I guess we can start our draw as soon as we have the location. That's really the big thing. So we're gonna do location query, iter, enumerate. Let's do it like this. So for index location in. Okay, so we have our location. Okay, so we're gonna need to do the entire thing where we get that out. I think we can start just drawing it essentially. So that location equals okay. And you're a point. Okay, so we cast you. Then better location equals. And we'll borrow you. All right, we're good to go for you. Very end here. Okay, that. What kind of result are we doing? We're doing just a core result. That's wrong. Wait, no, that is. Oh, it's the error result. Okay, that's good. Okay, so enumerate location, we borrow. Then we can do our graphics draw. And did that context. The drawable. Okay, so we need the mesh also. That's going to be our mesh query. Position index. I might be able to do this all in one go too here. So you're a reference to an RC. Ref cell of a mesh. Okay, so cast you. All right, just pass the mesh in. What's next? We have the draw params. And we're gonna have to set the color on this. So we need that here too. I don't think I can do a question mark here. Can I? Okay, it needs to be a let's see. Can I do that properly? Yeah, it's a ref. So I need to do something like dereference you and then reference you. I don't think that's as easy. Do we need to like clone you as a mesh? I don't want to have to do that. Can I wire you and dereference? Oh, I can like that. And then it's just the reference to the mesh. There we go. That works. Okay, and I can question mark you because you implement error trait. Nice. Then, okay, so that's our draw system. That should draw out all the particles now. Okay, fade the debris system. The idea here is, okay, so we're doing a query to get all of the colors, and then we all have these like ticks to live too. And then we're going to oh, right. So we're trying to make it like equal to like 0 here. So I guess the first thing that we need let's go ahead and comment you out. We'll start over again. All right. So the first thing is we need our colors. We need the wrapped debris color. And I only see one query. Oh, do we also need get resource? Okay, so we also need this, the get resource. Okay. So queries is only for components. Resources are very similar to here. I want to say that this is still something doable. Gives us an RC ref cell reference, resource. We have to borrow, okay, so the wrapped ticks to live. Then we cast you to U size. Okay, so that makes you happy. We need to query for this. Query is equal to your names, debris color. And we're only doing like a single query here, but I think I like the pattern of like keeping it separate. So let debris query. In case I need to add another one in here sometime. All right, so now we have our debris query. We have the wrap ticks to live. We're gonna take the debris color query. So for color in color query, we're going to have just a reference to our debris color. We can now cast that away. Okay, so you're going to be a type, reference to an RC, cell, ref cell, color. Okay, let debris color equals this equals debris colored cast. Why are you upset? Nothing expected. Huh. Expected semicolon. And let debris color is equal to debris color dot borrow. Okay, so now we finally have that. We can now access it using this. Okay, using that ticks to live, and then we're good to go. Okay, so then you can go away, and we're good to go here. Except for you. I don't know why you're still upset. Expected expression here. So let variable name colon with the type reference to an RC. I have open. Wait, open. Oh, too many closed. There you go. That's what it is. And then okay, your debris color, which means you need to be mutable. You need to be borrow mute. All right. Slowly taking care of these. I'm gonna keep closing all these windows to like clean up. Yes, save all of these. All right, next up. Update life and particle system. All right, so what are we doing here? We have wrapped ticks to live. So we're grabbing that out. Okay, so we're querying for all the ticks to live. This is the only query here, so we can replace you. Okay, so we're gonna do that, and then also let's just go ahead and grab 0 out to just get that ticks to live. Okay, so we have you. Ticks to live. We can't do the cast mute yet. That has to come later. Okay, so we can ticks to live, iter mute. We don't need the iter mute. We can just be an iter. We can enumerate. Ah, I see. We have this delete entity by index. Does that still exist? I don't think so. We need the ID as well. So let's not do this. We need the ID. Okay, so then we're gonna get ticks to live. So ticks to live, iter, enumerate. We have our for each, so we get the index, and then the tick to live, which is this component data. We have to, before we do anything else, cast it back. So it's gonna be let tick to live is gonna be a type. So I'm thinking that this, it would be really nice to have like a type up here. And I wonder if I can do that. Can I do something like, can I have a type with like a reference generic almost? Chantilly cake, hello, good morning. Okay, we have tick to live. That's gonna be a RC. Yep, we have our kitty cat here today. And then I want this to be like a T essentially. Like that. So can I do something like T there? Oh, type, and then this is going to be basically a component. Actually, it's really just going to be a wrapper. Is it like that? I don't remember how to do a type. Type name equals. Okay, so type name equals like that. Expected a name, so I can't do that. Now, okay, so cannot find type in this scope, and yeah. Can I do this? Maybe. Okay, so then down here, I want to, okay, so let tick to live, which is going to be a type of a wrapper. Oh, nice. Okay, so a tick to live, what did we decide this was? I think I forgot. It's a U32, right? I think it's U32. I32. I doubt that for some reason. Okay, then we can do a tick to live cast that. Yeah, there's no I32. So do this component data. Cast returns this result with an RC ref cell T. Oh, that's like that. Yeah, okay, I-32. It's not an I-32. Are you a U-32? I can go find out what it is probably pretty easily. What are you upset about? Okay, so tick to live dot cast. We have cast components. Ticks to live is this. Yeah, it's off of here. Tick to live. Okay, that's correct. If I remove you, what do you say that you are? Okay, yeah, that's correct. It's a reference to an RC ref cell with that unknown type. If I remove you, it says, look, it's a result. Oh, wait, are you the wrong type of result? Oh, right, because it's a for each. Oh, I totally forgot. I kind of want to, because I don't think we can do the try for each. Can I? Oh, I can. Okay, nice. So then you're going to be a reference to a wrapper with the U32, we think. We'll find out really quickly if it's the wrong type. Tick to live minus equals 1. Okay, so then we have to borrow mute you. Let mute tick to live. Tick to live dot borrow mute. All right, then we can tick to live minus equals 1. If tick to live is now 0, then we tell it to delete entity, but there is none of this anymore, so we have to delete by ID. And then we have to figure out what the ID of this entire thing is. So we have to get you now. So let ID equal to the IDs position index. We can also go ahead and cast you. So you're a wrapper of a size. Cast. Okay, so that gives us you. Okay, so that gives us, okay, an ID of this. Do we have to borrow it? I don't think I can just borrow straight off like this. No, because, yeah, I can't do that. I don't think I can do the cast with the typing here either. That would be really cool if I could. I don't think I've set it up that way. So I don't think I can do like a wrapper size dot borrow. Yeah. Wrong number of type arguments. None of you like to do that. So we'll do cast. We have to do you in a two-step process. Okay, so cast you. Then the ID is borrow. then particles world, delete by ID, and it's then just going to be destructured ID. Oh, you're not a U size. IDs are U32s. All right. Problem with you. Tick to live. Type annotations needed. I have them right here. What are you upset about? Okay, let's go make sure that that tick to live really is a U32. We can do this when we create the particles. Create chip debris. Ticks to live. Data ticks to live. It's a, oh, ticks to live is a U size. Oh. Oh, okay. So you are a U size here. You should be fine because I've got my type annotations here. I want to say that I've confused it. Okay, so then we exit out and we're good to go, I think. It'd be nice if this wasn't yelling at me anymore. But tick to live, this is component data. Cannot infer the type. You don't need to infer the type. I've got it right here. However, this has reminded me, I do want to come into our mod for the world. I want to add in that type because that seems really, really helpful for us. So let's just add in a pub type. And this is going to be a sort of like a wrapper. We'll call this a, it's both like a unit. It's a type wrapper. It's both for the component and the resource. I don't think it matters that much. So it's a, maybe like we call it a data wrapper. There we go. Data wrapper, we're gonna have this T here. You're gonna equal a RC with a ref cell of that T. So then I can remove this wrapper here and so you're going to be a data wrapper of U size. You are data wrapper of U32. Nice. To restart REST Analyzer, will that help? Which means we don't need these types explicitly in here anymore. They're now handled elsewhere. Okay, nice. All right, so I'm a little bit sad that this is still showing an error, but like I have a type. Oh wait, you're a reference. But yeah, like you're showing type annotations needed. Here is a type annotation right here. Where do you want the type annotations? And it is even this thing. Okay. All right, well, let's just continue on. All right, next up, update location system. So we're going to query for the locations and the velocities of all the particles, and then just sort of update them. So let's just do our standard thing. All right, step 1, we have to get the locations and the velocities. Okay, so we're going to be querying for names. Okay, the locations and the velocities. That's it there. Okay, grab you out. Then we're gonna loop through all the locations. Yeah, and just update those. So we can do a we can do the for each. We can do locations dot iter mute. No, I think it's just iter enumerate. This has to be a try for each. And here we're gonna have our index and the location. All right, so we need the current location. We need to like unwrap and get out the location, and we need to get out the velocity. So our location, which is going to be to a data wrapper of type point equal to location.cast. And then we can borrow that. Velocity. Data wrapper, you're also a point. So velocities, index, cast. Now, okay, location, you need to be borrowed mute. Okay, so we have that. Now we have our location and our velocity. We can now just update our location. Velocity. We'll return it okay. And there we go. Happy. Update life isn't yelling at me anymore? Cool. I'll take it. Particles is done. Collide with asteroids is next. All right. So get player index doesn't exist anymore. You're not being used, but you will be. You will be. Okay, so let's comment you out, and then we'll just figure out what we're doing one at a time. Okay, so if let some player ID. So we're getting the player index to find out if the player exists. And then we can grab everything else out. So we can do the same thing here. So if let some player ID is equal to, this is going to be the get player ID, and pass it in a reference to the world. Okay. You have the question mark U. All right, so now we have this option here. All right, so we have this. Then we need to query for, so we're colliding into all the asteroids. So we need to get all the locations, all the markers, so we can tell like if it's a asteroid or if it's like a player. We need to get all the sizes. We need locations, markers, and sizes. Okay, locations, markers, and sizes. All right, so we got locations, markers, and sizes out here. Now, Tigger Gauls, hello. How do you have both world and world mute? Oh, I have a particles world. I have two worlds. They're not it's not a singleton. I have two worlds, one for particles, one for everything else. And that's because like we're creating the particles world here, and yeah, I'm not like super happy with us like doing this at this point in time. It would be better to do this in a different system. Perhaps like have some kind of like message passing thing. I think we were talking about like that's one of the next things I want to like sort of do to learn. And actually, I want to note that down now before I forget. It's like in game dev, I want a new note. This is going to be skills, learn. And let's do, so for right now, this is going to be message, like event-based message, passing in, ECS systems. Something like the observer pattern that may be better for Rust. Then I can link to that from here. I'm experimenting around with Obsidian. I've heard and seen like a couple different things about it. It's a markdown editor pretty much. Like a lot of people are talking about like as a Notion replacement. I don't really see that, but it does have a nice little let's see, no orphans. It does have a nice system where I can have like groups where I can say, okay, I want path, match each of these. And now we could have, I could see like, okay, based on home, we can go to like game dev and then my skills to learn, and sort of like a graphical way of like seeing all of my my sort of like wiki pages all together. I don't know, it's an interesting idea. Okay, so world context, RNG. Okay, so we have all of these. I unfortunately had to like revert back to Grigalis to having the vector in the hash map for the components in order to facilitate using a bitmap and being able to do having entities with different number of components in them. It's sort of interesting the way that sort of like all went down, but I'm still really happy we like went through the entire path of learning. The other way would have worked if I did options, which would either way it complicates this side of things. Okay, so we've done our query now, so we have this down. All right, so then here we have our get the world respawn. Okay, so how long to respond? If I ignore that for right now, the entire idea of what I'm doing is I want to test to see, is my player. Okay, so we have the player ID. We have the player ID. You know what we should also query for? We should also query for the IDs. So let's do entity ID. So now I can do a single query and get them all out at the same time, which is also nice. Okay, so guaranteed, like even though not everything has like a size necessarily, or like a marker, the way this query works is all of these vectors are always going to be the same size. It just only chooses them if they all have them, which is really cool. So we know that asteroids and players have, and the player has the same number of marker, has a size, and has a location. And of course an ID, and we have the player ID, so we can compare against this here. Then I want to compare if I'm like, if we're too close, like if the player is too close to the asteroid. Now, does that mean, let's see, here's our query here. I'm just going to delete you to clean you up. We did that. Okay, the respawn time in there, we'll do that later. This is, oh, spawn player in, spawn time. Because I don't think we ever did anything with that yet, so I'm not gonna worry about it. Okay, so applications, we're doing all the casting. I don't need to do that right here. It's just done a different way now. Okay, then we have our player locations. So grab our player location out. I don't necessarily, do I need to do that? I do need the player location to be able to compare with everything else. So we do need to grab out the player location from here. It's not going to be quite as simple as we did before. We should probably find the player location elsewhere. So we can do that in a function down here. So function get player location. We're going to take in, I guess... Oh, get player index, really. So the index of these, and then we're just going to take in the player ID, which is a U32, and then all of the IDs, which is a vec. A vec of these components. Component data. And we're going to return... Now we know that it exists because we have a player ID here. We can maybe do like a result. I don't know if we need to, but we're definitely going to return something. Oh no, we definitely have to return a result because there might be an error. And then inside of here is going to be our U32. Wait, index, usize. Okay, so given these, I want to loop through all the IDs. So, and we're gonna get the index of it. So let's do like let index equals 0. This will make it a little bit happier in the end. I'm gonna turn an OK with the index. Then we can loop through all the IDs, getting the index at the same time. And as soon as we find the player ID, we're done. So we can just do a standard for loop here. So for, oh, this is the index. Do player index. Okay, so for index, and this is going to be the current ID in the IDs. Dot iter, dot enumerate. Okay, so we have our index. If our ID, okay, so then we need to let ID, which is going to be a type, a reference of a data wrapper, and you are a U32 equals ID dot cast. And then let we can borrow it. All right, so now we can compare. So if the player ID, if that's equal to a dereferenced ID, then player index, set that equal to index. And then brick. And then we return you. Okay, so now we have you. So let player index is equal to get player index. Pass it that player ID, and then pass it the IDs. Okay. Now, I probably don't want to take ownership of this vector, so let's make you a reference here. Although maybe I do. I don't know if I actually care. Let's go until it yells at us. I can question mark you. All right, so we have the player index here, which means we can now do this next thing, which is player location. Okay, so get the player location equals the locations of player index. And I think we should just go ahead and pass that to your reference to a data wrapper point. And we could borrow it right away too. All right. So now we have this location, iterate, enumerate. Okay, so we're going to loop through all the locations, and if you're an asteroid, then we're going to do this little fun thing. So we can do that. We do need the index out of here, so let do locations. Iter enumerate try for each, and we're gonna get the index, and what else are we gonna get? The location, then inside of here we need to cast out this location, so let location wrapper point. Okay, so now we have our location. Then what's next? If the markers of index, okay, so then we need to get the marker and compare it to this. And then delete the ship entity, then create the debris and all that fun stuff. All right, so we need the markers next. So let marker string markers of index past you. Okay, once we have that, we want to test to see if you are an entity type's asteroid. So if marker is equal to entity types dot asteroid to string. Okay, so if you're that, I think I can actually do this here. All right, so if marker is equal to this, then we also, okay, and the location dot distance to, okay, so, and location dot distance to I think it's the player location, right? Yeah, player location. So reference to player location. Let's do that here too. Oh, it doesn't like that. Mismatch types. Question mark. Okay. What are you upset about? You do that. Cast does that. Okay, so it's doing the same silly thing. Oh, Rust Analyzer, you're so good unless you don't work. Okay, so if marker player location distance to is less than sizes of index. So then, okay, so we have sizes. So we have to grab that out too. Data wrapper, I think the size is an F32. Okay. So if you're less than size, then a bunch of stuff happens. We're gonna delete the player. So we're gonna say world dot delete by ID and the player ID. We're also going to create the ship debris. So we have to do all that fun stuff. And that just gets, that's a helper function. So create, what was that? Create ship debris. Okay, so we pass in a mutable reference to the particles world, the context, RNG, which is all being passed through here, and then the location, which is actually going to be it's a point, right? So it's going to be the player location. Let me do that. Okay. Delete by ID does return a result. Create ship debris does return a result. Wonder if it's because I'm in a try for each and it's not happy. If I reach the end of this. Oh, because you don't know what you're returning, right? Because you're all different things potentially. Expecting intent like that. Okay. Okay, better. Better. Okay, so create the ship debris, and then respawn in spawn time. We're not dealing with that right this second, so I'm just gonna delete all of these, and I think we're gonna deal with the respawn later. We just want to make sure we can first destroy stuff. That being said, I'm out of time. It's 8:26, and I have to go get ready for work, unfortunately. So I'm gonna go ahead and start winding this down. But thank you so much for hanging out with me. I'm gonna go ahead and close off the YouTube video now. So if you're watching those, I'll see you next time.